Hello. In this video tutorial, we're going to be practicing Skills Practice 10.3, Potential and Kinetic Energy. Remember to have your calculator alongside you so that you can practice this independently yourself. Don't just rely on watching me do it for you. Make sure you can do it too. Well, before we begin, at the top of the page somewhere, go ahead and annotate so that we can see the equations we would use for kinetic and potential energy. Let's start with kinetic energy. Kinetic energy is 1/2 times mass times velocity squared. And there we go. And potential energy is mass times G times H. So there's a couple things we ought to know. I'm going to spread these out a little bit so we can see this. If you are given mass, you are given something in kilograms. If you are given velocity, you are given something in meters per second. Look for the units to translate to the variables you will use. If we are given M, we are given kilograms. If we are given mg, which is the weight, you are given newtons. And height, well, height's always in meters. G, the unit for G is acceleration, meters per second squared. Okay, so keep these in mind as we work through some of our scenarios. Okay, let's jump to question number 3. 1 and 2 were done in class. So let's take a look at number 3. Determine the amount of potential energy. So we're looking for potential energy of a 5 Newton book. So now what are we given here? Newtons, we're given a force. Newtons, we're given the weight, not the mass. So this, ladies and gentlemen, would be the weight equals mg equals 5 newtons. And we want to determine the potential energy of a book that is on a 1 meter high shelf, a 1.5 meter high shelf, and a 2.0 meter shelf. We'll call this H1, H2, and H3 for heights 1, 2, and 3 respectively. Let's scroll down to box number 3. Okay, we're looking for potential energy. We're given the weight of the book. As 5 newtons. You're also given height 1, height 2, and height 3 as 1, 1.5, and 2 meters respectively. The equation is M times G times H for potential energy. And what we'll do, ladies and gentlemen, is we'll go ahead and split the solutions box in 3 so that we can make the calculation for H1, for H2, and for H3. So we're just partitioning the problems that we're working on. So for the potential energy 1 involves the mass times G times H1. Now remember, guys, we're not putting in for mass. We're putting in for mg, the weight. So this is going to be 5 newtons times a height of 1 meter. And we get 5 Newton meters, which is the same thing as 5 joules. Potential energy on the second shelf, mg times H2. Again, you're substituting for the whole weight mg, not just the mass. So again, it's going to be 5 newtons times height 2, which is 1.5 meters. And from this, we get 7.5 Newton meters, or 7.5 joules. And for the third height, we have m times g times h3. Again, we're substituting for mg. So 5 newtons times 2 meters would be 10 Newton meters, or 10 joules. Let's take a look at number 4. Two objects are lifted by a machine. One has a mass of 2 kilograms. Since this is the first object listed, we'll call this mass 1. And it was lifted at a speed of 2 meters per second. Since that's the speed of the first mass, we'll call that V1. The other had a mass of 4 kilograms. We'll call that mass 2. And it was lifted at a speed of 3 meters per second. We'll match that with M2 for calling it V2. And it's asking which object had more kinetic energy while it was being lifted. So you have to calculate kinetic energy twice. Let's take a look. Okay, we saw mass 1 was 2 kilograms. Velocity 1 was 2 meters per second. We saw that mass 2 was 4 kilograms, and that velocity 2 was 3 meters per second. The kinetic energy equation is 1/2 mv squared. We're going to split the box in two so that we can make the calculation for each object. So object number 1, object number 2. Kinetic energy of object 1 is 1/2 m1v1 squared. And it's going to be 2 kilograms times 2 meters per second squared. Now to perform this calculation, we're going to start by squaring the speed. And the nice part about this is we have low numbers here, so you don't possibly need a calculator for this one. So try to follow along with mental math if you can. If you want to use a calculator, by all means, go ahead. But you start with the speed. 2, then square it. Well, now 2 squared is 4. Then we multiply times the mass. So 4 times 2 would be 8. Then the last thing we do is cut it in half, and we're back to 4. The kinetic energy of object 2 is going to be 1/2 mass 2 velocity 2 squared, which is 1/2 times 4 kilograms times 3 meters per second, quantity squared. Again, we're going to start with 3 squared, that's 9, times 4, that's 36, take half, well, that's 18. Four kilogram mass, 4 kilogram object has a greater kinetic energy. Let's take a look at number 5. In problem number 4, which object had more potential energy when lifted a distance of 10 meters? Okay, so now we're doing potential energy calculation. But we're given the distance or the height is 10 meters. So remember our calculations now. M1 was 2 kilograms. M2, the second mass, was 4 kilograms. We're looking for potential energy. You're looking for which one has the most potential energy, but ultimately you have to calculate potential energy. Right? And then G is 9.8, but please feel free to round up to 10 like I'm doing now. The equation we need is M times G times H. Let's go ahead and take a look. Potential energy for object 1 is M1G times H. So it's 2 kilograms times 10 for G times H is 10 meters high. So 2 times 10 is 20, times another 10 is 200 joules. For object 2, four kilogram mass times 10 for G, and then times 10 meters high. And 4 times 10 is 40. 40 times 10 is 400 joules. And there we go. The 4 kilogram object has the greater potential energy. Let's take a look at number 6. You are standing at the top of a large hill. Your potential energy is equal to 1,000 joules. Last time you checked, your mass was 60 kilograms. Okay, let's take inventory of what we know so far. I'm going to start in the givens box. We know our potential energy is 1,000 joules and that our mass is 60 kilograms. In part A, we're looking for the weight. In part B, we're looking for the height of the hill. In part C, we're looking for the speed at the bottom of the hill. We also need the potential energy equals mgh calculation, as well as the kinetic energy equals 1/2 mv squared calculation. All right, so what are we looking for here? Well, in part A, we're looking for the weight. In part B, we're looking for the height. In part C, we're looking for the speed at the bottom. Again, let's break this problem off into 3 sections. Partition it off, A, B, and C. Now for part A, pretty straightforward. We're looking for the weight. Weight is equal to mg. The mass was 60 kilograms. G is 10 meters per second squared. and we have a weight of 600 newtons. Now in part B, we're looking for the height. Well, we can use the potential energy calculation to get that, because we have the potential energy and we're looking for the height. So potential energy is equal to m times g times h. But if we're looking for the height, we need to divide by mg, which is the weight from part A. And we're going to go 1,000 joules divided by the weight, which is 600 newtons. Remember to practice this yourself, ladies and gentlemen. You get about 1.7 meters high. Finally, letter C, or part C, let's go up and read that part again. It says, if you're skating downhill, your potential energy will be converted to kinetic energy. That means at the bottom of the hill, your kinetic energy will be equal to what your potential energy was at the top of the hill. So what that really means, guys, is the potential energy at the top is also the kinetic energy at the bottom. It's also 1,000 joules. So I'm going to use my kinetic energy formula, and I'm going to solve for V, for the speed. Now to solve for speed, I'm going to start by multiplying both sides by 2. Two times kinetic energy equals mv squared. Now we're going to divide away the mass. Rewriting this again, and we get 2 times the kinetic energy divided by the mass equals v squared. Square root both sides to get rid of the square. And at this point, we can plug in 2 times 1,000 joules of kinetic energy the mass was 60 kilograms. And so we're going to go 2 times 1,000, which is, of course, 2,000. Divide that by 60, and then we're going to square root that answer. So we're starting with this times this, divided by the 60, and then square root. Put that in your calculator, right? And you should get about 5.8 meters per second.